Alright, so now that we're at the end of our unit, we've learned a lot of algebra and we've practiced it enough, hopefully to get a good feeling for it and a good mastery of it. It's time to just do a bit of revision, go over all the things we've learned, make sure it's really locked down, and we'll have a little go at an assessment this week. So what I thought might help you guys, if you haven't been keeping track of everything you've done in your glossary, I've basically got all the ideas and concepts in one spot with a little explanation. I'm going to put all these slides up on the Google Classroom so you can print them off and write all the answers on them, or you can just copy the whole thing down in your book if you want, but then you'll be able to refer back to this when you do your little tests and see if you can get things right. Okay, so you can then follow along and then write all your answers down as I do it in the video. So we'll start by going through our index laws, which is basically what we do with powers when we're multiplying and we've got algebra involved. So with index law 1, when we're multiplying things together, we have the same base. We multiply numbers like usual, but we're going to be adding our powers together because what powers mean I'm multiplying the same thing together. So if I'm multiplying something by itself, then there's going to be even more of those things together, right? So with this answer, we'll chuck a 20 at the front because we know what 4 times 5 is. And then index law 1 just helps me figure out how many y's I should put in my answer in terms of the power. All right, this is y times y, this is y. So we've got y to the 9, right? 7 plus 2, that's how many y's there are. When there are more letters involved, we just go one thing at a time. We'll put a 6 out the front because it's 6 times 1, no other numbers to times. Then the only question is, what power do I put on my A? What power do I put on my B? So the A gets a 7 because there's 3 of them plus 4 of them. And there's 5 B's being multiplied in this one times another B. No power there means there's just one more. So that's B to the 6, right? There's index law 1. Our second index law is just the reverse of what we just did. If multiplying gives me more of the same thing, then dividing gives me a bit less. So we just subtract the powers from each other. Right, so if I have 6 lots of t, right, that's t times t times t times t times t times t, there's 6 of them, and I'm dividing away 3 of them, I can then basically cancel out 3 on the bottom with 3 of them on the top, and I'm left with t. Right, we just take away those numbers from each other. Right, if you get numbers in your fraction, you'll either have to write down what the answer is as a whole number or as a fraction if they don't go into each other nicely. 4 divided by 2 is really nice, right? It's just 2, and then we just take away our y's from the bottom from some y's on the top, we'll be left with 2, right? 6 take 4 is 2. There's index law 2. When we've got brackets involved, the power on the outside of the brackets, there should always be a power there, otherwise we don't need brackets, should just multiply any powers that you can or can't see inside the brackets, right? This is applying to powers, right? Not numbers, but powers, because this is groups of things, right? The inside of this bracket, there are 4 lots of x, and there's 3 on the out, like we're being asked to have that 3 times, right? So if I've got 4 on the inside and I need that 3 times, that's just going to give me 12, right? Even if it doesn't make sense why it is 12, you just have to know that this power on the inside multiplies that power on the outside, right? So this 10 has to get the x and it has to get the y as well. The x has a power of 1 because there's no power written there. So 1 times 10 is 10, right? We've got 10 x's now all being multiplied. And the y is going to turn into a 30. All right, so with this one here, a little bit different because we have numbers here, like we have an actual coefficient, a number to go with my letter and my power. So the x part is easy, it gets a 6 because 2 times 3 is 6. What's really important to remember that when I put the power of 3 on this, that you're basically going 2 to the power of 3, right? This isn't 6, it's 2 times 2 times 2. Right, you got to think about it like that. Don't just automatically write 6, right? Because then you're treating it like a power, not like a number, right? So 2 times 2 times 2 ends up equaling 8. All right, so the numbers behave differently than the powers, right? But that's what happens when we've got brackets involved. If we wind up with a power of 0 in our work, we should then rewrite it to equal 1, because anything that has a power of 0 equals a 1, right? So we can simplify that down, right? It's nicer to write the number 1 than 4 to the power of 0. Doesn't matter whether it's a letter or a number. If it's got a power of 0, it equals 1. This one here, the b has a power of 0, the 4 doesn't, right? So the 4 is still there, multiplying the b0, or in this case, multiplying 1. So we can write that as 4. And then the easiest way to answer this one is to just see that the whole thing, this whole set of brackets, has a 0 on it. So the whole thing turns into a 1, right? We can use this to simplify our work. With index law 6, we don't like negative powers in our answers. They're not really simple to understand, but basically when I have a negative power, it means I've just divided and divided and divided kind of beyond whatever I started with, right? So if a power is repeated multiplication, a negative power is me dividing over and over again, and we can write divided bys as fractions. So I'm just going to say that I've got a 1 divided by x to the 3, right? I write it so it's not negative anymore. Right, I put it on the bottom to show I'm dividing by x 3 times instead of multiplying by x 3 times. Same thing here, put a 1 on top, because there's really nothing else to put on top, and put your y 5 on the bottom, it's not negative anymore. Right, same thing again, I see negative powers, I'm making fractions. So the x with the 3 goes on the bottom, but the 4 doesn't have a negative power, right? The 4 is just multiplying whatever is here, so we can put the 4 on top this time. Right, you can see that's different than here, where I didn't have any number at the front to put on top, so I just put 1. Then it gets more complicated because we've got a string of things, but set up a fraction, put your negative powers on the bottom, and take the negative out of it. Right, so actually take the negative out of it. Don't just say you're going to do it, actually do it. So this is x with a 3, and I'll put the z down there. It gets a 2. And anything that wasn't negative, like this and this, can go on top and just stay the same. Right, so all I did is I moved my negative powers underneath, and they're not negative anymore. That we can then use all of our understanding of these index laws and just other stuff we've learned about algebra to do sums that have adding, subtracting, or multiplying, dividing. The main thing you guys have to know is that they're different, and you have to do different things for adding and subtracting than you do for multiplying and dividing. The biggest problems we see students have with their algebra is they do multiplication things when they're adding, and they do adding things when they're multiplying. So we've given you some things to think about when you get a question on one or the other. So when you add or subtract, you can only add or subtract like terms. Those are things that are the same in terms of like their letter and their power. So you're looking for those matching variables, matching powers. When you add them, don't change the powers because that's what multiplication's for. So this question here is like adding and subtracting is really just a how many question, right? How many do I have of an algebra thing, right? The algebra thing can have letters and can have powers, but just ask how many and just change the number at the front. So this question is basically saying I've got 5 of something plus 2 of something, right? We know that 5 plus 2 is 7, and then our thing that we're adding just happened to be apple, like A cubes, you know, it could be cubed apples, right? Square-shaped apples or something. Doesn't matter what they are. We don't change what they are, we just change how many we've got, right? It's 7 lots of that thing, right? We don't make an A6, we're not putting the powers together, we're just adding the 5 and the 2. Multiplying and dividing do change the powers, so they're a little bit more complicated. So we can try and multiply and divide our numbers. This one's got multiplying and dividing all in the same question. We need to be good enough to do two things at once. But the easiest way to deal with a question like this is to just deal with the top first, right? We're going to leave that 5b to the power of 5 there. Just try and multiply the top. Right, we're just using our index laws. We put the 4 and the 3 together. That makes 12. We can put these a's together, right? Use the power rules, the index laws, to say that I've got 3 of them, right? 2 here, 1 there. And then b, I've got 7, right? 3 and 4 makes 7. And then we just see if we can actually simplify kind of across the top and the bottom, right? So we went side to side first. Now we can try and look up and down to see if we can cancel. Now the answer is still going to be a fraction because 12 and 5 do not go into each other. Right, I can't simplify that fraction, or I can't actually write an answer, right? If there was a 6 there, it'd be different, because I can go 12 divided by 6. The a has nothing to cancel out with it, right? There's nothing to simplify that down, so I leave my a3 alone. But we can see we've got b to the 7 on top and b to the 5 underneath, so I can use these 5 b's to cancel out 5 of them. So that's going to leave me with b squared on top, right? So I simplified going that way, then I simplify going that way. But we're only putting things together that are the same, right? I put my a's together, put my b's together, then I can put the b's together between the top and the bottom, and I'm done. The last two things that we learned were how to expand brackets to get brackets away from our work, and then to factorize it, put them back in. So with expanding brackets, we're going to have something on the outside and something on the inside, and the thing on the outside is going to multiply everything on the inside, right? The distributive property, distribution means sharing, really giving out. This a needs to be given out to everything inside the brackets, right? So we start by going a times 4a, right? And all that does is turn the a into an a squared, because look, we've got 2 of them, right? An a and another one. and put a plus in between, right? If you've got two things in your brackets, you're probably going to have two parts to your answers at least. So A times 5B, you need to have the 5, and then you put the A, and then you put the B. And you're done, right? Because A squareds are different than AB, so you can't simplify this down. Right, then you have to know how to expand and simplify. So we're going to put the 4B into this bracket. We'll start by doing that. So 4B times A. I'm going to go alphabetical order and put the A before the B. But I've just multiplied that by getting the A into it. And then I've got to go 4B times 3B. We put a plus in between because it's all positive. 4 times 3 is 12. And we've got B squareds. We then need to move on and deal with this one. It's important to note that this is a negative 3A, right? There's a minus there. We have to think about that as we go. So we're multiplying the negative 3A by the 2B. So a negative times a positive means put a minus, right? Don't automatically just go plus, plus, plus. You got to wait and see. All right, 3 times 2 is 6, and A times B again can just be written as AB. And then this negative 3A needs to multiply this negative 5. Two negatives does make a positive. I can put plus now, and I've got 15A. Then we have to check for like terms and see if we can put anything together, right? So we can put the ABs together. So the 4 ABs take away 6 ABs, right? I'm taking away more than I started with. I'm going to have a negative amount. So I've got negative 2 ABs. But then the other terms didn't have any like terms, so I can just put them in my answer, right? The 12B squared can join my answer, and so can the 15As. All right, so that's an example where you have kind of two of these things at the top. You do them one at a time, then you put your answer together if you can. Then we've got this last one, which is a bracket times another bracket. So as we've done a few times in previous lessons, each part of the first one has to multiply each part of the second one. So we start by getting the 4x in there. So 4x times 3x is 12x squared. 4x times minus 5 is minus 20x. We're done multiplying by 4x. So we're going to get the 7 in there. We're going to go 7 times 3x is 21x. And 7 times negative 5, again I've gone a negative times a positive, and that gives me minus 35. Then again we're on the lookout for like terms, and you'll usually find them in the middle with questions like this. Right, there are no other x squareds, so I can put 12x squared in my answer. And then I've got 21 take 20, or minus 20 plus 21. That just is 1x, so I can just put plus x, and then the minus 35 is there as well. Right, so that's a real crash course in all the kinds of expanding we've done throughout this unit. Right, finally, we've got factorization. So you're looking for something that goes commonly into both of your terms, and then you're going to put that out the front and divide it out and put some brackets around it all. So if you're looking at this first one, you need to find something that goes into 4 and into 12 evenly, the biggest best number there is. So 2 does go evenly into them both, but you want 4 because 4 is bigger and better. Then you open up your brackets, right? So when you're asked to factorize, that's how you should be setting it out, right? Don't try and put things together by taking or anything like that. Factorization means find a factor, chuck it out the front of some brackets, and start dividing each part one at a time, right? If you start with 2 terms, your brackets will have 2 terms in it. So 4x divide the 4 leaves x inside, and negative 12 divided by 4 is negative 3. Right, with the next one, we've got 2 negatives, and we're looking for things that are factors of both terms. So if they're both negative, you need to put a negative out the front, right? Only if they're both, right? This one only had 1 negative, so I didn't put a negative out the front. Right, so here's a negative for you at the front. I picked 3 because 3 goes into 3 and 9. And when I divide negative 3x by negative 3, negative 3 is gone, but x is still there. And I put a plus because I divide the negative out, and I'm left with a positive, and I've got 3. With the last two, we've got letters as well to factorize. The only thing that these two things have in common is they both got the letter x. So I'm actually going to factorize the x out. So we just need to think about what happens when I divide an x from each of these things. Right, so x squared meant I had 2 of them being times. I divide one out. I've still got 1x left. And this one, 3x divided by x, a bit easier to see. It's just 3. With the last one, there's a few parts to it. We're looking for what they both have. So we have to check if there's something that the numbers have in common. They're both in 7 times table, so we'll put a 7 out the front. And they both have at least 1x. Right, this one has more x's, but they both have at least 1. and they both have at least one y, right? We're kind of looking for the smallest amount of letter that they both have. So one term at a time, we start with this one. We just try and get these elements out of it. So we start with a 35 and get rid of the 7, so that leaves 5 because we're dividing. I had x cubed, and I divide 1x out, so I should still have 2 of them on the inside, so x squared. And we factorize the y out, so there's no y in this term. For the second part, start with a 3, because we go 21 divided by 7. It only had one x, and we factorized it out, so no x's in this term, and the y should have a power of 3, right? So that's factorization done. That's a real fast crash course in everything that we've meant to have learnt this term, and hopefully this will set you guys up for your revision and for your assessment that we'll all try and do online.